Alright guys, today our video is about the line of best fit, and in previous sections, we've kind of set this idea up as far as I've mentioned what the line of best fit is. But now we're actually going to graph the line of best fit and use it to predict some possible data points or some results that would come from the scatter plot that we're going to use. Two things I want you to keep in mind. When you're making a line of best fit, you want to try to do these two things. You want to try to go through as many points as possible. Okay. Obviously, if you have some data that you've put on a chart, and you want a line that describes that data, you want to hit as many as possible. And sometimes that's many of the points, but sometimes that's very few of the points. So that's okay. All right, we'll figure that out as we go. The other thing is number 2 here. Try to keep the same number of points on each side of the line. And again, that doesn't always happen the best. But you don't want like 10 points on one side of the line and 1 or 2 points on the other side of the line. That means you haven't really drawn the line of best fit correctly. All right, so let me take this off and let me put up example 1 here. This has got a lot of data to it. All right, what we're looking at is the size, and this is in square feet, of something that you go buy. I don't even have what it is, but this is the size of whatever you buy, and this is the price in dollars that it costs. So this may be like a house. All right, this may be, if you're buying a 5,232 square foot house, the price is 1,000,000 50 or 1,000,000, yeah, 1,050,000 dollars. But it may be something else too. It may be a boat, it may be land, it may be whatever. But we've taken all of this data and we've plotted the points for you, and we have this scatter plot right here. All right, and keeping those two things in mind that we mentioned before, we want to try to draw the line of best fit for these scatter points. All right. Now, again, I mentioned this all year, is I don't have a ruler that I can use to draw the line of best fit. But what I am going to try to do, I'm going to try to do my best to line up all of these lines, okay, or these points, I should say. And I'm actually going to use a little guide here on my pad that I'm using, on my tablet that I'm using. And, oh, that did a bad thing. I don't want to do that. All right. Actually, what I'm going to try to do here is I'm going to try to use a little guide so I get a nice straight line on this scatter plot here. So I've set up some points already. I've got this point. That's where I'm going to try to start my line, and I'm going to try to go right up this way. So let's see how I do here. I'm not trying to. There we go. Okay, let's start it there, and let's draw a straight line. Okay, that wasn't too bad. All right. So again, you can use a ruler, and yours will be nice and straight. But you see, I did hit this point and this point, and a couple points down in here. Now, if I count on each side, I've got 1, 2, 3, 4, 5, 6, 7 points over here. And on the other side, I've got 1, 2, 3, 4, 5, 6. So I've got 6 points on one side and 7 on the other. I've gone through 3 or 4 of the points. So that's a pretty good line of best fit right there. Okay. Now, once you do that, the whole reason why you do this is so now you can predict different square feet, how much they would cost, or vice versa. If I have so much money, what's the square feet that I could buy? All right. So let's turn on some of the questions here. There's questions that go along with this graph. What is the cost of the most expensive house? And where is that point on the scatter plot? Well, and really, you don't even need the line of best fit. That would be the point right up here. All right. And the cost, if I go straight over, it looks like, let's see, what are we going by here? Okay, so if we count the number of blocks, we have 1, 2, 3, 4, 5, and we've gone up 200,000. So if I divide those two, each one of these blocks is 40,000. So if I look at this point right here and I slide right over, it looks like it is above this second block right here, or I should say the first block above 100 or 1 million. So that is going to be approximately, this is going to be 1,040,000. This next block would be 1,080,000. So you could say somewhere in the 1 million, say 50,000. Okay, or you might even be 1,060,000. Okay, that is going to be an approximate cost. All right. Now the second one, estimate the cost of a 3,000 square foot house. Now this is where you want to really use your line, because you see where we have 3,000 square feet, we don't have any points around here, right? Well, we don't have one right on 3,000. So this is where the line comes into play. So you start here. Start with what they give you, and you go straight up until you hit that line, and you would hit that line right here, okay? And where you hit that line, then you just slide straight over, and if each one of these is 40,000, looks like we're right in between those two blocks. If this is 440,000, sorry, 480,000. 520,000. So I'm going to say this is 540,000, okay? Because it looks like it's like halfway in between. So I'm going to say $540,000, okay? So I use my line of best fit to answer some of these questions once I draw it on here, okay? If you notice, this question really is asking the same question as the one before. So we're going to go right on to this one over here. What is the prediction of the price of a 1,500 square foot house? Well, do the same thing. They gave me 1,500. Looks like each one of these, let's see, 1, 2, 3, 4, 5. Looks like each one of these blocks is going to be 200. So 1,500 would be right there in the middle between 1,000 and 2,000. All right, and if I go straight up, from here, we'll even put a little line in there for you. I'm going to hit that line right there. It looks like it's right on this block right here. Now, if your line of best fit is a little different, then you're going to get a little different answer. All right? It's all about drawing the best fit line as well as you can, and then matching up the coordinates here, or the data points. All right? So I would say that a 1,500 square foot house is going to cost you $200,000 if we're talking about houses. All right. Let's take a look at the other questions we have here. Oh, that was it. All right. Let me turn that one off. And let's go right into this next little set here. It says, considering the following general strategies students use for drawing a line. And what we're saying is a best fit line here. Do you think they represent a good strategy? All right. For drawing a line that will fit the data. All right, and it says Lori thought she might draw her line using the very first point, the one that's farthest to the left, and the very last point. All right, is this a good way to draw a best fit line? Well, let's do an example down here of why it is not. I'm saying it's not. So what if our points looked like this? All right, here's our scatter plot. Okay, and Lori's going to draw a line that looks like she's going to take the farthest one to the left, which would be that one, the farthest one to the right, and she's going to connect them. Would that be a good best fit line? No, because look at all these points are on one side, and all these points are, well, all these points, and there's no points on that side. So I'm going to say no to that one. All right, and an explanation would be, well, we did it through example here. You could draw that line so that you wouldn't have an equal number of points on both sides. All right. Okay, how about this one over here? Phil wants to be sure that he has the same number of points above and below the line. All right. Now, that is one of those two conditions we said at the very beginning. All right. So right away, I'd say, well, yes. Okay, I would say that would be a good strategy to use because no matter what you do, if you get the same number above and the same number below, that is definitely going to be a best fit line. All right, so how about this one? Sandy thought she might try to get a line that had the most points right on it. Okay, and if you remember again, back to those original conditions, that was one of the conditions as well. Try to get as many points right on it. So I'm going to agree with that one. Yes. Okay, that is definitely something you want to do. And how about this last one? Marie decided to get her line as close to as many of the points as possible. All right, and that really is the definition of what a best fit line is. So I'm going to say yes as well. All right, that one absolutely. That just goes right back to the definition. If you do those things, those two steps we listed at the very beginning, you're going to get as close to as many as the points as possible as well. So definitely yes with that one. All right. We have one more example to do. Let me clear the deck here and get that one up on the screen. All right, so here is what I called exercise 2. It really is exercise 3 because we had those questions in the middle there. But here's another exercise where we've already graphed the data from this table, and this is the speed of the river in relating to how deep it is. All right, and this is actual data from the Columbia River in Washington State. And what we've done is we've taken this data over here, the depth. The depth is along the x-axis here, and the velocity is along the y-axis, and we've graphed these points. All right. Now we want to do the same thing. We want to draw a line of best fit here. Okay. And I'm going to try the same thing here. I'm going to try to line up as best as I can with my makeshift ruler here. Oops, I got to get on the right layer here. Okay. And you go ahead and do the same. And I'm going to try not to put a point there. And I'm going to try to go to, where would I be if I'm there? Let's see. You take your ruler and you do the same. Okay, so I'm going to give this a shot. And yours may be a little different than mine, but I'm going to draw my line right in like that. What do you think? Did I do a good job? I don't know. I've got some points. Look, I got 1, 2, 3, 4, 5, 6, 7, 8 points over here, and I only have 2 points over there. I really need to shift my line. All right, I need to shift my line to the right here because I didn't even hit any of the points, did I? Okay, so let's see if I could take that line off. All right, let's take that line right off there, and let's give it another shot here. Okay, I'm going to try to line up here, and what if I drew it like that? How about that? Is that a little better? Let's see. I've got 1, 2, 3, 4, 5, 6 points over here and only 2 over there. Boy, I don't like that too much either. Okay? I really want to get a better line. Okay? And this may happen sometimes that you have to erase your line and redraw it. What if I drew it maybe like that? Is that a little better? Okay, I think I like that one a little better because I've got 1, 2, 3, 4. 1, 2, 3, 4, 5. I like that line a little better, okay? So I'm going to go with that line. All right, and now let's try to answer some of the questions here. Choose a data point in the scatter plot and describe what it means in terms of the context, okay? So let's just pick a point. Let's take this one right here. And what does that mean in terms of the context of the problem? Well, it tells us 2 things. It tells us the depth of the river, and it tells us the velocity of the river, okay? And that just happens to match up with, I believe, this point right here, okay? So that means that that point represents a depth, oops, let's put it up here, a depth of, how deep is it? 5.9 feet. And a velocity of, how much is that? 1.14 feet per second. Okay, so that's what it's describing in the problem. All right. Based on the scatter plot, describe the relationship. Well, what's the relationship? As depth goes up, look, as depth gets bigger, wow, velocity is actually getting smaller. All right, which is weird. You'd think it, as depth goes up, velocity would go up as well. All right, but this isn't the case in the data that we collected here. All right, so as, and it won't write on there again. That's odd. All right, let me see if I can fix it. As depth goes up, velocity goes down. Okay, and we've talked before about that being a positive or negative relationship. That is actually a negative relationship because my line of best fit is going down to the right. All right, how about the next set of questions here? Let's see what these look like. Let me turn off that. See if we can get rid of that stuff out of the way here. If the river, oh, I can't erase that. Okay. If the river is 2 feet deep at a certain spot, so that would correspond with that point right there. How fast do you think the current would be? Well, now we can use our line of best fit. Okay, 2 feet deep. Right? We go up until we hit the line, and then we slide right over to this point right here. And let's see, this is 1.4, this is 1.6, so it looks like every 2 blocks is 0.1. So that point right there would be 1.7. What's the units here? Feet per second. Okay. And how about the next one here? Use the line to predict the velocity when the water is 8 foot deep. Okay. Well, again, start with what they give you. We're starting with 8 foot deep. That would be right here. Okay. So I'm going to go up till I hit the line, and my line is right here. So I'm going to go over. It looks like I'm right on one of these lines right here. Okay, so I'm going over, and that one looks to be, if each one of these is 0.5, that would be 0.7 right here, and this is 0.8, so in between there would be 0.75 feet per second. All right, so again, using that line, let's turn that one off, and let's take the last question here. Use the line to predict the velocity for a depth of 8.6 feet. Wow, 8.6 feet. Again, 8.6. Let's see, these are going by 0.246. Nope, we're going by 0.25s. All right, so I'm looking for 8.6 would be approximately right there. And I'm going to go up until I hit the line. And it looks like I hit, again, right on one of these blocks. So I'm going to go all the way over. Oops, that wasn't good. I'm going to go all the way over till I hit right there. Okay, and again, this point is 0.5, this point is 0.6, so I'm halfway in between. That would be 0.55 feet per second. Okay, should be a C there. Alrighty, so there you have it. Just work on drawing a good line of best fit, and then being able to use that line to answer the questions accordingly. All right, so thanks for watching. Have a good night, and we'll see you tomorrow.